Okay, today is Unit 5, Day 7, and this is called Factoring Special Cases. So we've done a lot of factoring, lots of different kinds of ways of factoring. Now these are very focused kinds of factoring, and I think even if you've struggled with factoring before, these can be easier for you, I think. So one of them, they're basically just two kinds we're going to look at today, two different kinds of factoring, and they're very, very specific. And once you recognize them, they're pretty, just got to memorize what the pattern is. And, keep in mind that for the most part, it's only one of two things that you're factoring, one of two ways. So it's kind of easier to narrow down what you're supposed to be doing. So the first learning target, I will be able to factor and solve polynomial equations presented as a sum or difference of cubes. We've talked about sums and difference. We talked about difference of squares, not sums of squares, but difference of squares. Well, now we're going to talk about difference of cubes, and along with that, sum of cubes. So like right here is an example. If I had some number cubed minus another number cubed, there's a pattern for factoring it. It's right here, and we'll work on this a whole bunch. Now, if there was a difference of two squares, like we had x squared, get my hand out of the way here in a second, x squared minus 9, something like that. That's a difference of two squares. The pattern was x, so you square root the one, square root the other, plus minus. That was squares. Now this is cubes, so there's a difference here. And there was no factoring pattern for, say, x squared plus 9, because that was a sum. There was nothing. That was prime as far as you can factor. But with cubes, it can keep going. Okay, so with whether you're subtracting or adding, it's going to follow these patterns, and there's a lot of similarities. Maybe we'll get to that in a second. And then I can factor polynomials presented as special quartics. That's the other one. That's a backside. So if you've liked the last few days, like 2 days ago was polynomial division, very specific, one idea. Yesterday was synthetic division, very specific, same thing over and over. Well, today is going to be the same two things over and over. It's either a sum or difference of two cubes, or it's a special quartic. And we'll show on the backside a special quartic. So you just got to look at it, which one is it, and factor it. So it's a little bit more specific today, and I think that'll maybe, you won't spend as much time thinking, like, what am I supposed to do? Like, you'll pretty much see fairly quickly, hopefully. So if you look at these guys, either way, no matter what, it's the same pattern except for the signs. It's like they both start with A and then B in as a binomial, and then they have a trinomial with a squared, ab, and b squared. The only difference is the signs between them. Okay, so one of them has minus plus plus, the other one's plus minus plus. I think the easiest way to memorize it, well, first off, it always ends in plus no matter what. So the last sign, the third sign, is always plus. What it comes down to the difference is the first two signs. The first sign always matches. So if this is a minus, the first sign is going to be a minus, and then switch it to a plus. If the first sign is a plus, then that means this one's going to be a plus, followed by a minus. Okay, so the first sign matches what's given in the problem. The second one's the opposite. The third one is plus, no matter what. Okay, so it's pretty straightforward, I think. The hardest part, though, is trying to figure out what is A and what is B. So, like, what is being cubed here and what's being cubed here? So here's an example, x cubed minus 125. Okay, so first off, what is being cubed when I say x cubed? That almost seems like a trick question, but and how we figure it out is cube root it. Okay, so what's being cubed? X. Okay, here 125, what's being cubed? So what times itself 3 times equals 125. So what times what times what? Same thing over and over equals 125. So like 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. So 5 is that number. So my A is x, my B is 5. Okay, so think of it as my x is being cubed minus, and then 5 is being cubed. So there's my A and my B. So, and here's how I always do. I just do a binomial and a trinomial. So just put your parentheses in first, small gap, big gap. Fill in your signs next. okay? So if it's a minus in the problem, it's going to be minus, plus, and the third one's always plus. Now fill in your A and B. So the first one is just A, the second one is just B. This one is going to be A squared. So A squared would be x squared, because A is x. The next one is A times B, so I'm going to take 5 times x. Now you can say x times 5, but that doesn't make sense. We want to write it as 5x. The last one then is B squared. B is 5, so what's B squared? 25. Okay? And another really cool thing about when you're factoring sums and differences of cubes, this is never going to be factored further. Okay, so once you've done this, this is it. There's nothing else to do. Okay, so sometimes we say, well, could that factor further? Could that go to 2 binomials? This never will. You'll never be able to do it. If you want to check yourself, I don't expect you to check yourself every time, but if it's a test or a quiz, you got an extra 5 minutes, I wonder if I got that right. You can multiply this back out, and it equals x cubed minus 125. Okay, so if you have the time, or if you could just quickly check yourself on that, like x times x squared would be x cubed. The last, like negative 5 times 25 is negative 125. That you can kind of check those, and if those don't work, then you know you did something wrong. In fact, everything else in between cancels out. That's kind of the crazy thing about it, is a whole bunch of other things just wipe each other out. Okay, so here, next one. First off, identify, is this a perfect cube? So is there something I can multiply by itself 3 times to get 8x cubed? Well, what about 8? What times itself 3 times equals 8? 2. 2 times 2 times 2. What times itself 3 times equals x cubed? X. So A is actually 2x. And then 1. What's the cube root of 1? 1. So what I've really got here is this. Instead of 8x cubed, I actually got 2x, all of it being cubed. So that's my A, that's my B. Okay, so parentheses, little gap, big gap, fill in the signs. If this is a minus, it goes minus, plus, plus, and then fill stuff in. So it's AB, A squared, AB, B squared. A is 2x, B is 1, A squared. So what's 2x? The entire thing squared, so 2x times 2x would be 4x squared. AB, so 1 times 2x is 2x, and then B squared is 1. And that's your answer. It cannot go further. Nothing else can be done. Okay, so the next one, if I had 27x cubed, what's being multiplied 3 times to get 27x cubed? Well, for 27, the cube root of 27 is 3. 3 times 3 times 3 is 27. And then x. So A is actually 3x, B would be 2. So that's actually 3x, entire thing squared, plus 2, cubed. The entire thing cubed. So fill in your stuff. So little gap, big gap, fill in the signs. If this is a plus, it goes plus, and then the opposite minus, and the third one's always plus no matter what. AB, A squared, AB, B squared. So A is 3x, B is 2. A squared would be 3x squared. So 3x times 3x is 9x squared. AB would be 2 times 3x. 2 times 3x is 6x. And then B squared would be 4, because 2 times 2 is 4. Okay? Let's see, try this guy. So maybe pause the video and give this a try. Try to figure out what is A, what is B, and then go ahead and factor it. Okay, so hopefully, when you thought, what's being cubed to give me 64x cubed? It's 4x, because 4 cubed is 64, x cubed is x cubed. What's being cubed to give me 125? It's 5. And then I filled in my signs here, so since this is a plus, the first one matches it, then the opposite, then always plus. And start filling in. So A, B, A squared, AB, B squared. So 4x, 5, 16x squared. If I multiply this together, 20x and 25. Okay, now to solve, at the bottom here, the only difference now is we're going to add an equals to 0 at the end. So here I didn't have it equals anything, so you're just factoring and you're done. Here we're actually going to solve. Okay, so we're going to factor the formulas using this above. in front of this page that's up here. Set the first factor equal to 0 and solve, and then set the second factor equal to 0, but you're gonna have to use a quadratic formula. So go a little bit faster here. So here, this would be x cubed plus 2 cubed equals 0. So if I factor it, remember, small gap, big gap. If it's a plus, go plus, minus, plus. A, b, a squared, ab, b squared, x plus 2, x squared, 2x, and 4. So out of these two, if this equals 0, the first one's easy. So here x equals 2. So I can just say x equals, negative 2. So there's one of mine. That's a real solution. The other ones may not be real. Okay, they might be real, they might not be. There's probably a pretty good chance they're going to have an I involved. So I'm going to do the quadratic formula. So the opposite of b, so it'd be 2 plus or minus square root b squared would be 4, minus 4 times a is 1, times c is 4, all over 2 times a. And it looks like that would be 2 plus or minus radical, and this would be 4 minus 16, so it would be a negative 12 over 2. Again, don't cancel these 2's yet. Can't reduce those unless there's a 2 out front here. Well, let's see if I can do that with a 12. So 12, 4 times 3, 2 times 2. There's a pair of 2's, so I could have 2 plus or minus, pull that 2 out front, and pull an I out because it's negative. And what's left is 3 over 2. And now, since they all have 2's, then you can reduce those. So I could say x equals 1 plus or minus I radical 3. So it has one real solution, it has two imaginary solutions. Okay. For the sake of time, I'm gonna skip this part. So if you look over that again, it's always going to be opposite of this one. So if it's plus 2, negative 2 is your answer. This will always need quadratic formula. Remember, you can't factor any further; it's impossible. So you're just always going to use quadratic formula on that, and give me answers for quadratic formula. Okay, backside now, a little bit simpler here. Hopefully, a little bit more straightforward. But all of these, again, these are quartics. We want to make something. It's called, well, you can say a variable substitution. We call it a substitution. You can use whatever letter you use. You can change it to whatever you want. But this maybe looks familiar to some of you, maybe not. What if I said this? What if I said and I'll just use the letter A. Let's let A equal x squared. So everywhere I see an x squared, I'm going to put an a in its place. So I'll put an a here. It may not look like it, but x to the fourth is the same thing as x squared squared. Or power to a power, you'd multiply those together. So this is the same thing as x squared would be a squared. And now if I said factor this, I bet a lot of you could factor that. Okay, if it's a squared minus 13a plus 36, because now it's just two binomials. What two numbers multiply to give you 36, add to give you negative 13. On this one it'd be negative 4 and negative 9. And now let's plug that back in. Let's let a equals x squared. So wherever I see an a, I'm going to put x squared back in its place. So x squared minus 4, x squared minus 9. And now are these factorable? Well, x squared minus 4 is the difference of two squares, so that's actually x plus 2, x minus 2, and this is actually x, the difference of two squares, x plus 3, x minus 3. So that can be factored down pretty far. They don't all go that far, but this one did. And basically, if you see there's three of them here, you see an x to the fourth and an x squared, do this trick. It kind of reveals the quadratic form to you, or it's actually this form, and we've done a lot of practice with that. Let's do another one real quick. So a equals x squared. So here, instead of x to the fourth, think of that as x squared squared. So that'd be a squared plus 3a minus 4. So the two numbers multiply give you negative 4, add to give you positive 3. And now replace the x squared. So x squared minus 1, x squared plus 4. Okay, this one can go further, that one cannot. That's a sum of two squares. Remember, you can't factor a sum of two squares, but difference two squares, x minus 1, x plus 1, and this guy, just leave it alone. Just going to repeat it. Okay. Let's see, this guy, I'll just maybe, well, no, make sure, like before you do this one, also look, is there something they're all divisible by? Like here, they're all divisible by 2. Okay, and then let a equals x squared. And if you go all the way down with that, I'm just going to write down the answer down here, and you can give it a try if you feel like you need to try it on that one when you're all done. Okay, so there would be the answer for that once you're all done. Yeah, let's go this. We'll try this guy too. So this one here, there's no x squared in there, but think of this again. Let a equals x squared. So x to the fourth is actually x squared squared, so that'd be a squared. Can you factor this? Okay, that's a difference of two squares, so it'd be a plus 5 times a minus 5. Put the x squareds back in. Some of you may not need this step. It really does help a lot of people, but I know there's maybe 10 to 15% of you in Algebra 2 don't really need that intermediate step. You can kind of see it without doing that. You might be able to see like, well, if this is x to the fourth, x squared times x squared is x to the fourth, and there's no middle term, so what two numbers multiply to give you negative 25, add to give you 0? Well, it's negative 5 and 5. Now if I said keep going from there, actually neither one of these are factorable, so that's it. That'd be as far as you got to go. Now down below, if you see, I basically repeated the same problems. So number 1's the same, 2's the same, 3 is the same, 4 is the same. It's just now we need to solve. So I'm going to use my answer from above here. I'm going to write this down here because I've already factored it. So I factor this to x plus 2, x minus 2, x plus 3, x minus 3. Now that equals 0 instead of just being like up here. It was just there. It's a term. Or an expression, and down here it's actually equaling something. So what would x equal? If I said to actually solve it, it would be negative 2, it would be positive 2, negative 3, and positive 3. Okay? Pulling this guy down, pulling my answer down. X minus 1 times x plus 1, x squared plus 4. If that equals 0 now, and I'm supposed to solve this guy, well, two of these are easy. This would be a plus 1, this would be a negative 1. What answers would this provide? Well, I'll have to set x squared plus 4 equal to 0. Bring the 4 over. They equal negative 4. And now when I square root, x is going to equal. And since there's a negative there, there's going to be an I involved. Since it's the square root of 4, 2's in there. And because I square rooted, I have a positive and negative root. So this would be plus minus 2i. So you actually have 4 answers there. It is x to the fourth, so you have 4 answers, two real answers, 2 non-real, 2 imaginary answers. Okay, so I think I'm going to leave these guys go. I think same idea. Just take the factored form, set it equal to 0, negative 2, positive 2, and on this one here you'd have, bring the 10 over, so it'd be plus minus radical 10, and so on. So, video's already probably too long, so I'm going to cut it off there.